Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. Have you ever watched a sci-fi movie where an astronaut's helmet cracks and they instantly freeze or explode? It makes for great drama, but what would really happen if you took your helmet off in the vacuum of space? The reality is both less explosive and far more terrifying. Let's break down the science behind this ultimate nightmare scenario, second by second. The moment your helmet is gone, the first and most immediate problem isn't the cold or the lack of oxygen. It's the lack of pressure. Space is a near-perfect vacuum. Here on Earth, we live under a constant blanket of air pressure, about 14.7 pounds per square inch at sea level. This pressure is pushing on us from all sides all the time, and our bodies are perfectly adapted to push back. Without the external pressure, things go wrong very, very quickly. Within the first few seconds, the air in your lungs would expand violently. If you tried to hold your breath, the pressure difference would be so great it would rupture the delicate tissues of your lungs, forcing air bubbles into your bloodstream. This is called barotrauma, and it's a critical, often fatal injury. So the first counterintuitive rule of explosive decompression is to exhale. Force all the air out of your lungs. It's your only chance to avoid immediate and catastrophic internal damage. Simultaneously, something else bizarre would start to happen. The fluids on the surface of your body, the moisture on your tongue, in your eyes, and the sweat on your skin would instantly begin to boil. Now, this isn't boiling from heat. It's boiling from the lack of pressure. The boiling point of a liquid depends on the pressure around it. At sea level, water boils at 100 degrees Celsius. In a vacuum, the boiling point drops to below your own body temperature. This phenomenon is called ebullition. So your saliva would boil off your tongue and the tears would boil out of your eyes. It would be incredibly uncomfortable and disorienting, but this surface boiling isn't what would kill you. What about freezing? Space is incredibly cold, right? Yes, but it's not an instant deep freeze. Heat transfer needs a medium. On Earth, you lose heat quickly to the cold air or water around you. In the vacuum of space, there's almost nothing to transfer your body heat to. You primarily lose heat through thermal radiation, which is a much slower process. You wouldn't freeze solid for hours long after other things have gone terribly wrong. So you've exhaled and your surface fluids are boiling. What's next? The lack of oxygen. After about 10 to 15 seconds, you would lose consciousness. The oxygen stored in your blood would be used up by your brain, and once it's gone, you'd simply black out. This is a small mercy, as what follows is not pleasant. Even though you're unconscious, your body continues to react to the vacuum. The lack of external pressure would cause the tissues in your body to swell dramatically. You wouldn't explode like a balloon in the movies, because your skin is surprisingly strong and elastic. But you would swell up to possibly twice your normal size. Your skin would be stretched taut, and you'd look like a puffy, unrecognizable version of yourself. This swelling is due to the nitrogen dissolved in your bodily fluids coming out of solution and forming gas bubbles in your tissues, along with the continued effect of ebullition within your body. Meanwhile, your circulatory system would be in chaos. The low pressure would cause those gas bubbles to form in your blood as well, creating a kind of fizz in your veins and arteries. This would create blockages, stopping blood flow. Your heart would continue to beat for a short while, but it would be pumping against an impossible system of bubbles, unable to circulate blood or oxygen. Brain death would follow shortly after you lose consciousness, likely within a minute or two. So to recap the grim timeline, in the first 1 to 2 seconds, lung rupture if you hold your breath. Within 5 to 10 seconds, surface fluids boil and you begin to swell. At around 15 seconds, you lose consciousness from hypoxia. After that, your body swells up, your circulatory system fails, and irreversible brain damage occurs within about 90 seconds. Total survival time, even if you were rescued within that first minute, is extremely unlikely. The damage from the swelling, the gas bubbles in your blood, and the oxygen deprivation would be too severe. There have been a few real-world accidents that give us a glimpse into this. In 1966, a NASA technician was accidentally exposed to a near vacuum in a test chamber. He lost consciousness in about 14 seconds. The last thing he remembered before blacking out was the saliva on his tongue beginning to bubble. Luckily for him, the chamber was repressurized very quickly, within 30 seconds, and he survived with no lasting damage. This incident confirms the rapid onset of unconsciousness and the strange phenomenon of ebullition. Another incident involved a Soviet crew during the Soyuz 11 mission in 1971. A valve on their capsule depressurized. accidentally as they were re-entering Earth's atmosphere. The 3 cosmonauts were exposed to a vacuum at high altitude. When the recovery team opened the hatch, they found the crew deceased. An autopsy revealed they had died from hemorrhages in the brain due to the vacuum exposure, causing the oxygen and nitrogen in their blood to bubble. These stories underscore the absolute hostility of space. It's not a place that forgives mistakes. It's why astronauts train for years and why every piece of their equipment, especially the helmet and suit, is a marvel of engineering designed to keep their fragile, Earth-based biology alive in an environment that wants to tear it apart. The spacesuit is, in essence, a personal mobile Earth environment providing pressure, oxygen, and temperature regulation. So the next time you see a movie character's helmet shatter, you'll know the truth. They wouldn't explode. They wouldn't instantly freeze. They would face a rapid, silent, and systematic shutdown of their biological functions, beginning with a final, desperate gasp to empty their lungs. It's a sobering reminder that we are creatures of this civic planet, perfectly tuned to its atmosphere and pressure. Out there in the silent dark, we are incredibly, profoundly fragile. How about we explore what would happen if you fell into a black hole, the real dangers of space junk, or if humans could survive on Mars without a spacesuit? Let me know your choice in the comments. Thanks for joining me on this deep dive into the harsh realities of space. If you found this interesting, make sure to hit that like button and subscribe for more explorations into the fascinating and sometimes frightening world of science. Let me know in the comments what other space myths you want me to tackle next. Stay curious, and I'll see you in the next video.